Hi, so in this video, this is our first lab for a series of labs we're going to be doing that I spoke about in a previous video. In this lab here, we're simply going to use this topology here and just get our minds wrapped around Cisco IOS. As a review, you should already be somewhat familiar with Cisco IOS, but it never hurts to get a little review. So by the way, these labs are available on my GitHub repository, both the packet tracer files and the lab document that you see here. This is designed for my students, but anybody is welcome to them. So let's take a look. So here's the lab document here. What we're going to be doing in this lab here is configuring host PC0 and PC2. All the other hosts have IP addressing configured. So we'll be doing these two hosts right here. We'll also be configuring basic Cisco IOS commands and IPv4 addressing just for remote access, SSH telnet, on these layer 2 access switches. And we will be configuring, let me move this over a little bit, layer 3 switches, both Cisco IOS commands and IPv4 addressing, as these are layer 3 switches. I'll be talking more about that. I have a separate video on that as well. We will be using these as routers. All righty, so let's go ahead and get started. Okay, so the first part here, we're going to just do some basic iOS configuration, but starting with, before we do iOS, configuring the PCs. I am going to move this document. Well, I'll tell you what, I'll just leave it right there so we can scroll back and forth here. So now let me go ahead and move it off to the side here. There we go. So I can take a look. All right, so let's go to PC0 here. Just going to go right here, going to go to config, and we're just going to configure the IP addressing statically. So I'm going to make this one here 10.10.1.100. And the mask that we want is actually a /24, 255, 255, 255.0. And I'm going to go up here to global settings and make sure that this is going to be my default gateway right here. We're going to do that on the layer 3 switch / router in a moment, but that's going to be 10.10.1.100. Let me move that out of the one, excuse me. So that you can see that. All right. All right. So that does it for PC1. Let's go ahead and do the same similar for PC2. And as we can see here on PC2, it's going to be the 10.20.1.100. So let's go to Fast Ethernet 0 there. 10.20, get that out of the way. 1.100, again, same mask. Okay, /24 mask. Let's go here, and its default gateway is going to be distribution 1, but on this interface here, 10.20 1.1. Okay. Now, the way that we've got this topology set up, and I mentioned previously, each one of these is a separate network or subnet, same thing. And we've done that throughout. So each interface on one of these distribution switches, layer 3 switches, routers, is on a separate IP network. And as we'll see, all of these will be separate IP networks as well. But this is one local area network segment here, another local area network segment here. Okay, I think we've got the layer 3 switches configured. Or I'm sorry, gosh, Rick, the IP, I'm looking at my document and talking to you at the same time. Got the PCs configured here and here, so we're good there. I want to show you on the document before we get started here on configuring the layer 2 switches. On my document, this explains the basic iOS commands. So let me just use this to go over it with you. We're going to use enable to enter privileged exec mode, then go and use configure terminal, config T, to enter global configuration mode. We're going to configure a host name. We're going to use no IP domain lookup, prevent iOS from searching for a DNS server after we've done a typo. Enable secret class, create a privileged exec password, then go into line console 0. Logging synchronous, this prevents iOS output from interrupting our CLI. Exec timeout 00, this prevents time. This just leaves us logged in. So iOS won't time us out, but this should be in a lab environment only. You would never do that in production. Password Cisco for the console password, login, exit, and then our virtual terminal, what we used to call virtual terminals. This is for Telnet and SSH, line VTY 0 space 4. We're going to do transport input Telnet. That, again, lab only. Normally we'd use SSH, but just to keep things simple for here, Telnet's fine. Password Cisco, login, exit. So login provides the login prompt. And then let's go ahead and go back to global configuration mode. Service password encryption. This encrypts the console and VTY passwords in our running config. Not the best encryption. So it's really just to keep somebody from looking over your shoulder. There's a better way of doing that, but won't go through that here. Banner message of the day. This is our delimiter. So this is our text. Notice here's the end of the delimiter. So as soon as we type that, that's the end of our banner message of the day text. Now, layer 2 switches. They do not need an IP address, but we will configure IP addressing just so we can remotely access this switch using, in our case, Telnet. Okay, we need an IP address to access it. So we're just going to use the default interface VLAN 1. In my other class, my other series of videos, we talk about VLANs, and you'll notice this topology is very similar to that. Just a little, we're not doing VLANs and trunking and first hop redundancy protocols. Check out that playlist or take my other class and we go through all that. So anyway, here's the IP address for this switch. Notice it's on the same network as these devices here. Then we'll do a no shutdown on that, although we don't really need to. It should default to that. Now, just like our computers, PC0 here, needed a default gateway to communicate with devices outside this network, so does our switch if we want to remotely access it from another device. Let's say PC2 wants to remotely access Access 1. We need to make sure Access 1 knows how to send packets back to a device on another network. Just like your computer needs a default gateway to send packets to or back to a device on another network, so does a switch, layer 2 switch. So it's acting like a host. Here's its default gateway, which will be the same as the computer on that network. Okay, and copy run to start. Okay, now, suggestion. Okay, I like to copy all of this stuff into a text file. Okay, and you can actually just use mine here if you wish, but let me show you what I mean by this. So I'm going to create a little text file here. Okay, let me show you what I'm doing here. So here's a little text file, and by the way, this here just means that these are commented out, but let's just copy all this here. Okay, so you can put all those commands that we just went over, put them in a text file like this here. And this is what I'm doing in this lab, by the way. I have a text file already built for all this. So making sure everything looks good. Okay. All I need to do is select all of this, copy it. Let's move this out of the way here for now. Then I'm going to go here to Access 1. CLI, give myself a little room here. Make sure I'm at a prompt, and then make sure you use this paste here in Packet Tracer. Okay, now, first thing I'm going to do is scroll up here, make sure I don't have any errors. Okay, so everything looks fine. I don't see not seeing any errors. And you notice I did the copy run to start. You might have noticed here, make sure you give yourself a couple of blank lines there. Okay. You need that because it's going to ask you destination file name, and that blank line will just be a character return, and it will then save it. Now, after you do this, make sure not only have you copied the running config to startup, but Rick is a little bit paranoid. I always am saving. So I'm going to save this as my demo here. Okay, there we go. And save. All right. All right, so now it's pretty straightforward. I have a configuration file I'll show you already built that I did for the other switches. The only difference I did for each one of these is, you'll see right here, different IP address. Okay, this one here is on the same network, but a different IP address. And of course, where are we? A different host name. Okay, now I'm calling these access because they are access switches. Okay, just to make the point clear. Okay, so what I'm going to do is copy this. Now I'm just going to come down here, access 1-2, do the same thing. Paste. Okay, let me go ahead and do these here. Access 3. This out of the way. Fine, there we go. There's my config. I'm just going to move that out of the way for now. Okay, I'm going to grab my I need to make sure I didn't have any mistakes on the other one, don't I? Okay, but I'll do that in a moment. Okay, here's access 3. Gonna paste. Let's make sure no mistakes. Notice this one here. There's the default gateway, different network. IP address, different network. Let's go back to access 1-2. Like I said, we should make sure that we didn't have any mistakes. Okay, I don't see any errors there. That's good. That's great. Let's move that out of the way. Let's see, access 3, got that done. Let's move that out of the way. We have one more to do here. Okay, so I'm going to copy my script for 1-4. Let me grab that. Paste that in. Make sure everything looks okay. All right. All right, I think we're doing good. All right, so let's take a look at what our lab says now to do. Okay, so by the way, the lab gives you the IP addressing of all the access switches. So that looks good. All right, so now next it says configure the edge router. So again, similar commands. The one difference that we are going to be doing is we are going to be configuring IP addressing on the 3 interfaces. So let's take a look at that. Let me zoom in here. All right. Let me close this here so it gives us a little bit more room. Okay, so this is our edge router. Notice that all these links, the link lights are showing red, meaning that they are down. actually administratively down. Because we don't have any carrier signal being received from any other device. So anyway, we'll get there in a moment. But we're going to be configuring 3 different IP addresses for 3 different networks. This edge router is what connects to our internet service provider, our ISP. This is the interface that will connect to our internal network, which is the 10 network, 10.0.0.0/8, subnetted into /24s and /30s. But we also have a public-facing network. This is where our public web server is, and it's on the 209.10.10 network. We'll talk more about that later. But we're going to configure the IP addressing for all of this. So let's go ahead and get started. Let me just go to the edge router here, CLI. And again, I have a script for all of this. Okay, so let me grab my script. And then we can see what Rick did. Okay. I'm going to do a paste here. Okay, let's make sure everything looks good. Okay, so here's my basic iOS commands. Okay, enable secret, line console, line VTY. Everything looks similar as we did the access switches, but we also configured IP addressing. So we went into each interface. I gave it a description, which is optional, but good practice. Then I gave it the IP address, and we have to do the no shutdown. Okay, so 3 different interfaces on 3 different networks. Then we did copy run to start, and everything's looking good so far. All right, let me move that out of the way. You know what I'm going to do? I'm going to save. There we go. So easy. All right, next we are going to configure these distribution layer 3 switches, but they're going to be acting as routers in our network. Okay, I talk more about layer 3 switches in my other set of videos in my other class, but you'll see that on the other playlist. All right, so basically everything's going to be the same as our layer 2 switches. Okay, so let's go ahead and at first just configure distribution 1 and distribution 2 with basic iOS commands. So let me go ahead and do that. So I'm going to grab my basic configuration here for distribution 1. Let's do distribution 1 first. We'll do the whole thing. So let me just distribution 1, CLI. Make sure you have a prompt before you do the paste. Make sure I copied that. And do paste here. Okay, and everything looks good. Basic iOS commands. All right. So next what I'm going to do is actually I'm going to configure the IP addressing. I'm going to configure just like we did on the router. Each one of these interfaces will have its own IP address. So we actually have 1, 2, 3, 4, 5 interfaces on 5 different networks. Notice that these 2 interfaces are on /24 networks. These 3 are on /30 networks. I'll talk about those in just a moment. Let me go ahead and do the configuration of all 5, and then we'll talk about the /30. Okay, so let me do a paste. Okay, there we go. So let me talk about this configuration. Each interface has put the description. I'll come right back to that in a moment. Here's the IP address command, no shutdown. Why did I do the no switch port? The no switch port tells this layer 3 switch that this is not a switch port, meaning it's not a layer 2 port. Well, if it's not a layer 2 port, what is it? It becomes a layer 3, what we call a routed port, meaning it acts as just like a port on a router. We can give it an IP address. I'll show on distribution 2 what happens if you do not include that command. If you do not include this command, the iOS will not accept this command here. I'll do that on the next one so I can show you that. Okay. All right. Now, one other thing I need to mention here. And right now, by default, this model of layer 3 switch does allow you to make a routed port. But right now, this layer 3 switch is really kind of nothing more than an end device. I mean, it's not acting as a router. Let me show you what I mean. I'm going to do an end here. Show running, not show running config, show IP route, excuse me. And notice this doesn't have a router's routing table. It has a routing table that actually is more like a end device, a host computer, because it's not acting as a router, not yet. We need one command to do this. Now, right now, this device is like PC0, okay? It does know that it's connected to 5 different networks. Of course, PC0 knows it's only connected to one network. So it could reach devices, directly connected devices on any of these networks. There's other things we could do to make it act like a typical host. I could even do static routes as long as it's not routing. What I mean by this is right now it is not routing. It will not forward packets from devices in one network to devices in another network down here. And I can't do, well, let me show you, config T. If I try and configure OSPF, okay, IP routing not enabled. That should give us a clue. We need routing enabled, so let's do that. IP routing, that's all we have to do. Now it's acting as a router. Matter of fact, let me do show IP route. We will see it has a routing table. Now, Packet Tracer has a little bug in it. I mean, this is all correct, shows directly connected networks. What it doesn't show, and it should, is the local address on each network, but that's not a big deal. Okay, so I'm going to do my copy run to start, since I didn't run my complete script. There we go. Let me move that out of the way. Okay, let's go ahead and do distribution 2. Believe it or not, we're almost done. Okay, with distribution 2, what I am going to do is just do the basic commands first. So let me get us to a prompt. Paste. Okay, did Rick do everything right in my, again, I'm just using my script here for all of this. And all of these commands, I'll show you in a moment, are in the lab. Well, I showed them to you already, but just some of the changes that you have to make are all in the lab. Okay, so I'm in global configuration mode. Now, on distribution 2, we have also 1, 2, 3, actually 4 interfaces that we need to configure. No, 5. 1, 2, there's the other one. I knew there was 5. 1, can't really see it. See right there? There we go. 1, 2, 3, 4, 5 on 5 separate networks. Let me go ahead and do the interface gigabit 0101 right here. Okay, so I'm on distribution 2. Show you what happens. So I'm going to just do paste here. I got the interface in there. Okay, what if I try to configure the IP address right now? Okay, remember I didn't tell it that it's a that this port is a layer 3 routed port like a router. So right now it thinks it's a layer 2 Ethernet switch port. Okay, so let's go ahead and just IP address 10.30.2.1 to 255.255.255.0. Okay. And when I hit enter, notice it says, I don't recognize this command. Okay. The reason is I haven't done IP routing. Once let me exit out of this first. Not IP routing, no switch port. Rick, it's early morning for me. Okay. Haven't done the no switch port yet. IP routing, I haven't done yet either. We'll get there. But this is the command. So don't listen to Rick all the time. The no switch port command is what I need to allow this to take place. There we go. I'm looking at one document. I'm talking to you. I'm thinking about something else. So sometimes I get a little crazy here. So no switch port. That's what I need to allow this to happen. Now let's just hit the up arrow. Okay. And there we go, twice. Now let's do that IP address command. There we go. Okay. And I'm going to do a no shutdown just to make sure it's up. Exit. And then I'm going to go ahead and just copy and paste from my script the addressing for the other interfaces. Okay, so there's my other interfaces. Okay. Now you can see some of these are /30s. We'll talk about that in a moment. I'll show you my lab document. I have information for you on that. Now again, show IP route. No, it thinks it's just a regular host with 5 interfaces on 5 different networks. So let's do config T, IP routing. Okay, now let's go back, show IP route. There we go. Let's do our copy run to start. And we should be good to go on that. All right, we're really done, but let me go over something here on the lab with you. Make this a little wider here. Okay, so the lab document talks about all this, including, don't forget that no switch port. Okay, gives you all the commands. Okay, I also talk about the /30 addressing. Okay, so /30 addressing is what we use typically a lot of times on point-to-point links or inter-router links. An inter-router link is where we only have routers at both ends. In this case, layer 3 switches acting as their ports acting as routed ports. So let's just call them routers. There's only 2 IP addresses, host addresses needed, one here, one here. So we have a network address, one host address, 2 host addresses, and a broadcast. So one of the simplest ways to conserve IP addresses, even private IP addresses, private IPv4 addresses, is to use a /30. Now, there's a way to use something called a /31. I won't go into that. And there's other ways to even do even more conservation that I won't go into. But anyway, so so what I did was I took one of our /24 networks and I divided it into /30s. It's like taking a slice of pie and then dividing it into smaller slices. And that's what I did here. So what we can see here is here's the networks. So let's, I think this is for the 10, 200, 100 group of networks /30. So I took 10, 200, 100 divided into /30s. Okay, so 4 would be the network address. 5 and 6 are the host addresses, 7 for the broadcast, which then makes 8 the next network address, 9 and 10, the host addresses, 11 for the broadcast. This is showing it in binary. So here's our network address right here. This is the network portion of the address. So so what we did is I took this /24 and divided it into multiple subnets. Each one, all zeros in the host, 2 bits reserved for the host. Oops. And I have 0, 1, and 1, 0 for each host. Of course, 1, 1 is the broadcast. You can read through this if you want some more information on this. But that allows us to use, to conserve IPv4 addressing, which is not an issue in IPv6. IPv6 subnetting is so much easier. Okay, so I talk about all that here. I also talk in the lab document about IP routing on layer 3 switches using the IP routing command here, making sure we're doing that. Okay, and then let's go ahead and verify connectivity. So I've already shown you the routing tables on distribution 1 and distribution 2. Okay, let's do some other verifying as well, and then that will get us close to finishing all this up. Okay, so what I'm going to do is I'm going to let's go to PC0 here. Okay, we configured IP addressing on that. By the way, all the other PCs are configured, and I should mention that all the other routers have the basic iOS commands and interface commands already configured. This is all you have to do in my lab for this to get started. Okay, I'm going to go to desktop, command prompt. Let's do IP config. And we can see there's our IPv4 address. There's our default gateway. Great. Okay, let me do ARP-A. Notice there's no ARP entries right now. Let's make sure that we can reach a device in our own network. Let's see if we can reach PC1, ping 10.10.1.101. That's reachable. Notice if I look at my ARP table now, I now have the MAC address for PC1. Okay, let's make sure that we can reach our default gateway. So I'm going to do a ping here and reach our router, our default gateway. Let's look at the ARP table again. Notice now that I have an ARP entry for the IP address of our router, our default gateway. Now remember, ARP entries will only contain IP addresses for devices in our network. So what happens when I try and ping? Let's try and ping PC2 here. 10, whoops, ping 10.21.100. A little pause here. Why that first one timeout? Well, let's talk about that. Okay, because if I do it again, there is no timeout. Okay, all right. Let's look at the ARP entry. So again, not a new ARP entry, of course not, right? Because that packet to 10.21.100 is encapsulated in an Ethernet frame that goes actually to the default gateway. Now, why did that first one time out here? Okay, most likely because either the router here had to do an ARP request and get the MAC address of the PC. That's most likely what occurred. So that first one timed out. After that happened, the other pings were successful. Also, what this tells us is PC2 is knows how to get back to us. It has a default gateway, yes, 10.21.1, and distribution 1 knows how to get back to us. Okay. Let's do a couple of final little tests here. Let's see. What I'm going to do here is test to see if we can reach 10.32.100. This should fail. Why? We haven't done routing yet. Okay, but let's make sure that. Okay, I'm getting destination host unreachable. That is because distribution 1 does not know how to get to that network. Let's look at distribution 1. Here's the routing table for distribution 1. Move that right here. Let me bring this up right here. This is the network we're trying to reach, 1032.100. That's nowhere in its routing table because we haven't configured routing yet. We will be doing that, OSPF. That'll be the next lab. It's not in there, so it dropped the packet. Okay, distribution 1 dropped the packet. Okay, so yes, we did expect it to fail. That's what we wanted. Okay, so we should know what should succeed, what shouldn't succeed, and why. All right, a couple more things. Let's take a look at, eventually we'll be able to reach servers up here like 11110 and other devices. Let's make sure that we can't. Ping 1.1.1.10. Yeah, destination hosts unreachable. That's what we want. Okay. All right. But let's try this. Remember, I mentioned Telnet, right? So let's go down here. PC1 should be able to telnet into both of these switches. First of all, can it ping it? Remember the IP address that we put on there? 10.10.1. Oops, made a mistake there. There we go. Yes, it actually had to do an ARP request and get the ARP reply from it. Okay, so it can ping that switch. Can it ping the other switch? Okay, good, good. All right. Let's see if we can actually telnet into it. 10.10.1.5. Oh, made a mistake. There we go. There we go. Yes, Cisco, enable, class, exit. Now, why did we put that default gateway on the switch? Let's take a look. Let's go to access 1-3. Okay, so what was the IP address for that? Let's make sure we can ping it. 10.20.1.5. I believe that was the IP address. There we go. So now it should be no problem. So the reason why we can ping it is our packets got there, okay? We sent so our ping from PC0 went to our default gateway. Great. Now it's your job, distribution 1, to handle this. Distribution 1 says, no problem. I'm directly connected to that network. After getting its MAC address, I forward the packet to what it's considering right now kind of a end device, access 1-3 at 10.21.5. That's its IP address. Remember, access 1-3 has a default gateway. Let's take a look. Remember, I talked about the default gateway right here. There's access 1-3. Here's its IP address. And it says, okay, yes. Oh, I need to send packets back to you, an ICMP echo reply. Yes, I have a default gateway, just like PC2 does. I have a default gateway distribution 1 on this interface. So let me send those packets back. That's why we need this default gateway here. For packets going back in this case. Okay. So our ping works, so should telnet work? Let's do that. 10.21.5. There we go. Look at that. Okay. So right now, these devices can all reach each other. We can even telnet into the switches. Same thing here. These devices, I've already done all the configuration of all these. All of these. So all these distribution switches, routers, okay, they all have IP addressing. Everything has iOS configured on it, all these access switches. But these distribution layer 3 switches, routers, none of them are configured for a dynamic routing protocol or even static routes. They do not know about remote networks. The only networks any of these distribution layer 3 switches, routers, the only networks they can reach is their own directly connected network. So in the next lab, we'll be configuring OSPF. Let me back out of this a little bit so you can see where we're headed, so that these devices will be able to reach devices in other networks, because these routers here, let's call them routers, will learn about remote networks, including how to get out to the internet. So we'll be doing that in the next lab. Okay, I'm going to save my lab. There we go. I hope you found this useful, and I'll see you in the next lab.